All right, let's take a look at the practice test. For the instructions, we want to find the values of the 5 trigonometric functions not given. So coming down here for problem number 1, we have that the tangent of theta is 2/3 and that the sine of theta is less than 0. So the first thing if you have a problem like this is to figure out in what quadrant does your angle theta lie. So what we would do is put the information together. We would start with the fact that the tangent of theta is 2/3, which is a positive value, and that the sine of theta is less than 0, which is obviously a negative value. So in the lesson, we talked about a little trick for remembering where the trigonometric functions are positive and where they're negative. So essentially, you can remember the all students take calculus. So let me set this up. In the top right of your coordinate plane, this is quadrant 1. We're going to go counterclockwise. So this quadrant over here is quadrant 2. This one down here is quadrant 3. And then this one right here is quadrant 4. Okay, so if you can just remember that you're starting at the top right and it moves counterclockwise, you'll be good to go on this. Now, I mentioned all students take calculus. Let's write that out. So all, I'm just going to put an A. Students, I'm going to put an S. Take, I'm going to put a T. And calculus, I'm going to put a C. So what this tells you is that in quadrant 1, all of the trigonometric functions are positive, okay? As you get into quadrant 2, everything is negative except for sine and cosecant. And you get that from that S, right? So you remember S is sine, and then the reciprocal of sine is cosecant. So these are both going to be positive in quadrant 2. Everything else is going to be negative. In quadrant 3, everything is negative except for the T stands for tangent, and then also the reciprocal, which is cotangent. And then in quadrant 4, everything's going to be negative except for the C stands for cosine, and then also the reciprocal, which is going to be secant. Okay, so this is how you can remember the positive or negative status for each trigonometric function. Again, it's going to be all students take calculus. Okay, so just keep repeating that. Now, in this particular example, the tangent of theta is a positive 2/3. So the tangent of theta is positive in quadrants 1 and 3. Then we're told that the sine of theta is less than 0 or negative. Well, the sine of theta is negative in quadrants 3 or 4. So putting the two pieces of information together, it's going to tell us that this guy right here, this angle theta, is going to lie in quadrant 3. So I'm going to come back up, and I'm just going to say that this is going to be our angle theta is in quadrant 3. So we're just going to write that out, and we'll remember it. Now, in terms of getting the other 5 trigonometric function values, what we'd have to do is figure out a point on the terminal side of our angle theta. Now, with the tangent of theta, by definition, this is y over x. So the mistake a lot of students make is they just say, okay, well, y must be 2 and x must be 3. But again, if you thought about that, that would be the ordered pair 3, 2, right? And where is that? That's in quadrant 1, right? So this is 3 units to the right and 2 units up. So that would be a point right there on the terminal side, but that is not consistent with the information we're given. So what's going on? Remember, if you're in quadrant 3, the x values are negative and the y values are negative, so a negative over a negative would give you a positive. So you just have to adjust this and say that, well, this would need to be a negative 3, comma, a negative 2. So in other words, a negative 3 for x and a negative 2 for y. So going 3 units to the left and then 2 units down. So right there, that would be your pointer on the terminal side. And if you wanted to draw this out, let's say this is at the origin. So let's go this right there. And then let's sketch that like that. So this would be your angle theta. Okay, so you can draw that out if you want to. As you get better at these problems, you won't need to. So this is the point we're going to use. This negative 3, comma, negative 2. So coming back up here, I'm just going to put the ordered pair negative 3, comma, negative 2. Or you could write this out and say x is equal to negative 3, y is equal to negative 2. Of course, we need our r value. And let's calculate that real quick. So the r is equal to the square root of x squared plus y squared. So negative 3 is your x. If you square that, you get 9. And then plus negative 2 is your y. If you square that, you get 4. So r here is the square root of 9 plus 4, which is the square root of 13. So the square root of 13. Okay, so once you have this information, you're actually done with this stuff. You're just going to come down and just fill in. You can write everything out first if you want. So the sine of theta is y over r. And then let's put the cosine of theta is going to be x over r. So for the next one, the reciprocal of sine is cosecant. So the cosecant of theta, this is going to be r over y. And then remember, y cannot be 0. So in all of these, the denominator can never be 0. And then for your next case, the reciprocal of the cosine is going to be secant. So let's put the secant of theta, and this is going to be r over x. Again, x can't be 0. And then we already know what tangent is. The tangent of theta, that's given to us as 2/3. And then your reciprocal for tangent is cotangent. So let's put cotangent of theta. And I'm just going to flip this, so it's going to be 3/2. So really, we just need to plug in and figure out these guys. Or you could just plug in and figure out this one, and then flip them to get these two. Okay, so it's pretty simple. So for y over r, the y value is -2. So I'm going to plug that in there. And let me just plug that in here as well. And then your r value is going to be the square root of 13. So let me put the square root of 13, and let me put the square root of 13. Now, for this one, I would just put the negative out in front, and you're done. For this one, you would rationalize the denominator. So multiply this by the square root of 13 over the square root of 13. So that's going to be -2 times the square root of 13 over 13. So let me put a 13 down here. Let me just fix this up and say this is the negative of 2 times square root of 13, and this would be over 13. Okay, so that's your answer there. So we have these three, and then I need to get these two here. We already have this one. So for x, it's going to be -3. So let me put that in there, and then also there. And then for your r, again, it's the square root of 13. So the square root of 13, and then here, the square root of 13. And again, for this one, I would just move this negative out in front. So for secant of theta, it's negative square root of 13 over 3. For the cosine of theta, you need to rationalize the denominator. So let's multiply this by the square root of 13. And then down there by the square root of 13. So this would just be 13. And again, you can move this negative out in front if you want. It's not necessary, but I like to do it. So this would be all of the 6 trigonometric function values. Your sine of theta would be negative 2 times square root of 13 over 13. Your cosecant of theta would be negative square root of 13 over 2. Your tangent of theta, which was given, is 2/3. Your cosine of theta would be the negative of 3 times square root of 13 over 13. Your secant of theta would be negative square root of 13 over 3. And your cotangent of theta is going to be 3/2. All right, let's take a look at problem number 2. So we have the secant of theta is equal to the negative of the square root of 5 over 2. And then we have the sine of theta is greater than 0, or you could say positive. Going back to our coordinate plane, if the secant of theta, which is the reciprocal of the cosine of theta, if that guy is negative, where does that happen? Well, that happens in quadrants 2 and 3. And if the sine of theta is positive, where does that happen? Well, that happens in quadrants 1 and 2. So again, putting those two pieces of information together, that tells you your angle theta is going to lie in quadrant 2. So coming back down, we would say that theta is in quadrant 2. So now that we have that piece of information, we know that the x values are going to be negative and the y values are going to be positive. Let's just write out that the secant of theta is equal to what? Remember, it's the reciprocal of the cosine of theta. The cosine of theta is x over r. So the secant of theta is r over x. Now, this guy right here is negative. So that comes from a negative over a positive or a positive over a negative. In this particular case, we know that r is going to be positive, right? So x must be negative, and that's consistent with what we have here because, again, in quadrant 2, x values are negative. So I'm just going to say that my x value here is going to be -2, and that my r value here is the square root of 5. Okay, so we have two pieces of information. Let me get rid of this. Now, I need to figure out the y value, and then I'll be good to go. I can just start plugging in. So y is equal to what? Well, to figure that out, let's plug in what we know. So we know that r is equal to the square root of x squared plus y squared, and r here is the square root of 5. Well, we know x is -2, so -2 squared would be +4. So what we could do here is just square both sides of this equation, and this would give me the square root of 5 squared is going to be 5, and this equals the square root of 4 plus y squared is going to give me 4 plus y squared. So I would just subtract 4 away from each side, cancel this away, and so we're going to have y squared is equal to 1. So let me get rid of this, and let's just write out that y squared is equal to 1. Now, from your square root property, we know that if y squared equals 1, y is equal to plus or minus the square root of 1, right? The square root of 1 is 1. So y equals plus or minus 1. Now, y is going to be positive 1 because in this particular case, we're in quadrant 2. So in quadrant 2, the y values are positive. We know the x values are negative. So I'm going to choose positive 1. So let's write everything out. We will say that the sine of theta is y over r. We'll fill this stuff in a minute. Then the cosine of theta is x over r. We know that the reciprocal of sine is going to be cosecant. So the cosecant of theta is going to be r over y. And the reciprocal of cosine is secant. So the secant of theta is going to be r over x. Now we're given this one, so we can take this one and plug it in. And then we also can just take the reciprocal of this one to get this one. We'll do that in a moment. Then we have the tangent of theta, which is y over x. And then the cotangent of theta, which is x over y. We were told that the secant of theta was the negative of the square root of 5 over 2. It's cut off right now, and I'm not going to scroll back up, but that's what it was. So the negative of the square root of 5 over 2. You can just flip this guy to get this guy. Remember, secant and cosine are going to be reciprocals. So I'm just going to erase this and put this as negative. You have 2 over the square root of 5. And go ahead and rationalize the denominator. So I'm going to multiply this by the square root of 5 over the square root of 5. So this would be the negative of 2 times the square root of 5 over 5. All right, for the other guys, for the sine of theta, let's plug in a 1 for y. And then for r, let's plug in the square root of 5. You're going to rationalize that, but before you do, just flip this guy to get this guy. Because they're reciprocals, you'd have the square root of 5 over 1, which is the square root of 5. So this guy, you'd multiply by the square root of 5 over the square root of 5. So you get the square root of 5 over 5. So this is the square root of 5 over 5, like this. And then coming down here, for y, you're going to plug in a 1. And then for x, you're going to plug in a negative 2. So let's just say this is negative 1/2. Again, the cotangent of theta, you just flip this guy. So the reciprocal of negative 1/2 is going to be negative 2. So this is negative 2. So the sine of theta is the square root of 5 over 5. The cosine of theta is negative 2 times square root of 5 over 5. The cosecant of theta is the square root of 5. The secant of theta is given to us. It was negative square root of 5 over 2. The tangent of theta is negative 1/2. And the cotangent of theta is negative 2. All right, let's take a look at problem number 3 now. So we have the tangent of theta is equal to the negative of 2 times square root of 5 over 5. And the sine of theta is less than 0. So if the tangent of theta is negative and also the sine of theta is negative, where's that going to put us? So the sine of theta is negative in quadrants 3 and 4. The tangent of theta is negative in quadrants 2 and 4. So that tells me that we're going to be in quadrant 4. So let's put that theta is in quadrant 4. Okay, so knowing that the x values are positive and the y values are negative. Okay, so we're given that the tangent of theta is equal to the negative of 2 times square root of 5 over 5. We know that tangent of theta, so the tangent of theta is y over x. In this particular case, I know that the y values have to be negative and the x values have to be positive. So let's go ahead and say that x is going to be positive 5 and that y is going to be negative 2 times square root of 5. Okay, so I just need to get my r value going. So let me scooch this over here and say that r is equal to the square root of, you have x squared plus y squared. So your x value here is 5. 5 squared is 25. And your y value here is going to be negative 2. So negative 2 times the square root of 5, and that's going to be squared. Let me put my square root symbol back in. So if you square negative 2, you get 4. Right? And then you would multiply by the square root of 5 squared is going to be 5. So this is going to be 4 times 5 or 20. So let me put a 20 in there. So essentially you have 25 plus 20, which is 45. And 45 would break down into 9 times 5. And 9 is a perfect square. So this is 3 times square root of 5. So r is going to be 3 times square root of 5. Okay, so we have everything we need. So let's go through here and say that the sine of theta is equal to y over r. The cosine of theta is equal to x over r. The cosecant of theta is equal to r over y. The secant of theta is equal to r over x. Your tangent of theta, which is given to us as the negative of 2 times square root of 5 over 5. And then your cotangent of theta, which can be found, let me make this theta a little bit better, by just flipping this guy. So you would have the negative of 5 over 2 times square root of 5. You would rationalize the denominator there. So multiply by the square root of 5 over the square root of 5. So before you multiply here, the square root of 5 times square root of 5 would be 5. And that would cancel between numerator and denominator. So you're going to get the negative of the square root of 5 over 2. So the negative of the square root of 5 over 2. So let's go through and get the rest of these guys. So for my y, I'm going to plug in the negative of 2 times square root of 5. And then for my r, I'm going to have 3 times square root of 5. And of course, square root of 5 over square root of 5 is going to cancel. So this is just negative 2/3. So negative 2/3. You could flip this to get your cosecant of theta. So this is negative 3/2. For the cosine of theta, it's going to be x, which is 5, over r, which is 3 times square root of 5. Let's rationalize the denominator. I'm going to multiply by the square root of 5 over the square root of 5. So again, you have square root of 5 times square root of 5, which is 5. So this would be 5 down here. So 5 divided by 5 is 1. So this is square root of 5 over 3. So square root of 5 over 3. Now for this one, you could flip this. But what I did was I rationalized the denominator first before I flip this. So it makes it a little bit harder. So what I'm going to do is actually just plug in. So for the r value, again, that's 3 times square root of 5. And then for the x value, it's 5. Okay. So for the sine of theta, we have negative 2/3. For the cosine of theta, we have square root of 5 over 3. For the cosecant of theta, we have negative 3/2. For the secant of theta, we have 3 times square root of 5 over 5. For the tangent of theta, we have negative 2 times square root of 5 over 5. And then for the cotangent of theta, we have negative square root of 5 over 2. All right, let's take a look at problem number 4. So we have the cosecant of theta is equal to the square root of 17 over 4. And then the cosine of theta is greater than 0. So this is positive and also this is positive. So going back, we think about the fact that cosecant is positive in quadrants 1 and 2, right? Cosecant is the reciprocal of sine. And then additionally, we're told that cosine is positive. Well, that's only going to be in quadrants 1 and 4. So that tells me I'm in quadrant 1. So let's put that theta is in quadrant 1. Okay, so now that we know that, the x values are positive and so are the y values. So coming down here, for the cosecant of theta, this is going to be r over y. So that tells me that r is equal to the square root of 17 and that y is equal to 4. So I just need to figure out what is x. So to do that, again, you just plug in to your r formula. So r is equal to the square root of x squared plus y squared. So we know r is the square root of 17. So let's fill that in there. And then for y, it's 4. 4 squared is 16. And then just square both sides. So I'm going to square this side and square this side. You're going to get 17 is equal to x squared plus 16. Let's go ahead and subtract 16 away from each side of the equation. So let's get rid of that from over there. So this cancels. So you're going to get x squared is equal to 1. And we'll say x squared is equal to 1. Again, from the square root property, that tells me x is equal to plus or minus 1. But essentially, you want to choose positive 1 because we're in quadrant 1. And x values and y values are both going to be positive. So I want to say x equals 1 here. So let's scooch this down and say that x is equal to 1. What I would do here is write out my sine of theta, which is going to be the reciprocal of this guy. So it's 4 over the square root of 17. But again, you have to rationalize the denominator. So let's multiply this by the square root of 17 over the square root of 17. So this is 4 times square root of 17 over 17. So 4 times square root of 17 over 17. And then you have your cosecant of theta, which is given to us. Again, this is the square root of 17 over 4. Let me slide down here. Then let me write the tangent of theta. And this is going to be y over x. Let me just fill it in now. So this is 4 over 1, which is just 4. And then let me write the cotangent of theta, which is the reciprocal of this. So this is 1/4. Okay, so all we need is the cosine of theta, which is x over r. And you need your secant of theta, which is going to be r over x. Okay, so for the cosine of theta, your x value is 1. And then your r value is going to be the square root of 17. And again, before I rationalize the denominator, let me flip this now so that I don't have to do extra work. So this is the square root of 17 over 1, which is just the square root of 17. Okay, So this guy right here, you would rationalize the denominator. You'd multiply by the square root of 17 over the square root of 17. So that's going to give you the square root of 17 over 17. So the square root of 17 over 17. Your sine of theta is 4 times square root of 17 over 17. Your cosine of theta is square root of 17 over 17. Your cosecant of theta is the square root of 17 over 4. Your secant of theta is square root of 17. Your tangent of theta is 4. And your cotangent of theta is 1/4. All right, let's take a look at problem number 5. So we have that cotangent of theta is equal to -4/3. And then we're given that the cosine of theta is less than 0, or you could say negative. So the cotangent of theta is negative and the cosine of theta is negative. So again, coming back up here, if we think about where cotangent is negative, it's going to be negative in quadrants 2 and 4. If we think about where cosine is negative, it's going to be negative in quadrants 2 and 3. So that tells me that we're going to be in quadrant 2, right? So cosine is negative and also cotangent is negative. So let me put here that theta is in quadrant 2. Okay, so we know in quadrant 2 the x values are negative and the y values are positive. So looking at this, we are given that the cotangent of theta, so the cotangent of theta, which is x over y, is equal to -4/3. So we know that the x values are negative and the y values are positive, so that tells me that x is going to be equal to -4 and y is going to be +3. Okay. Let's get rid of this. We just need to figure out what r is. So let me slide this down here. So this r is equal to the square root of x squared plus y squared. So x here is -4. -4 squared is 16. Plus y here is 3. 3 squared is 9. 16 plus 9 is 25. So this is the square root of 25, which is going to be 5. So let's go through and write everything out. So we have the sine of theta is y over r. And then you have your cosecant of theta, which is r over y. And then you have your tangent of theta, which is y over x. But again, you can just flip the cotangent of theta. So this is just -3/4. So we already have that one. Let me make this a little bit better. And then let me write this over here. So the cotangent of theta, just so we have it, this is going to be -4/3 like this. So let's write the cosine of theta. That's going to be x over r. Let me make this theta a little bit better here. And then we have the secant of theta. That's going to be r over x. Okay, so now we'll just plug in. For the sine of theta, for y, it's 3. And for r, it's 5. And again, you can just flip this to get the cosecant of theta. So this is going to be 5/3. And then for the cosine of theta, you have an x value that's going to be -4. We put the negative out in front. And then the r value is 5. So this is -4/5. Again, for the secant of theta, just flip that. So it's going to be -5/4. So your sine of theta here is 3/5. Your cosine of theta here is -4/5. Your cosecant of theta is 5/3. Your secant of theta is -5/4. Your tangent of theta is -3/4. And your cotangent of theta is -4/3. All right, let's take a look at problem 6 now. So we have the tangent of theta is equal to -2/3. And then we have the cosine of theta is greater than 0 or positive. So again, if the tangent is negative, that's only going to happen in quadrants 2 and 4. And the cosine is positive, that's going to happen in quadrants 1 and 4. We know we're going to be in quadrant 4. So let me just say that theta is in quadrant 4. Okay, so that tells me that the x values are positive and the y values are negative. So if you have something like the tangent of theta is equal to -2/3 like this, well, this is y over x. And again, the y values are negative, the x values are positive. So that tells me that x is going to be +3 and y is going to be -2. Okay, so we just need to figure out what is r. Let me drag this over here a little bit. And we'll say that r is the square root of x squared plus y squared. So 3 squared is going to be 9, then plus -2 squared is going to be 4. So 9 plus 4 is 13. So r is the square root of 13. Okay, so sliding down here, we will say that the sine of theta is going to be y over r. And again, you can just plug this in as you go, or you can write them all out. It doesn't really matter. Let's just say this is -2 over the square root of 13. I will come back and rationalize the denominator in a moment. Remember, we need to flip this guy. So the cosecant of theta is going to be the square root of 13 over -2. But let's put the negative out in front like that. Let's put our cosine of theta as x over r, so 3 over the square root of 13. Again, I'll rationalize the denominator in a moment. Then we have the secant of theta, which is going to be the square root of 13 over 3. And then we have our tangent, which is given as negative 2/3. So then the cotangent would be negative 3/2. So let's write the tangent of theta is negative 2/3. Again, that's given. And the cotangent of theta, just take the reciprocal. This is negative 3/2. All right, so for this one and this one, I'm going to rationalize the denominator. And in each case, I'm going to multiply by the square root of 13 over the square root of 13. Let me move this negative out in front. And we'll say this is 2 times square root of 13 up here, and then 13 down here. So over here, I'm just going to say 3 times square root of 13 over 13. Okay, so we have everything now. So the sine of theta is the negative of 2 times square root of 13 over 13. The cosine of theta is 3 times square root of 13 over 13. The cosecant of theta is negative square root of 13 over 2. The secant of theta is the square root of 13 over 3. The tangent of theta is going to be negative 2/3. And the cotangent of theta is negative 3/2. All right, for problem 7, we have that the secant of theta is equal to 5/4, and the sine of theta is less than 0. So the secant, which is the reciprocal of cosine, is going to be positive. So that occurs in quadrants 1 and 4. And then we're saying that the sine is negative, so that's in 3 and 4. So we'll say that our angle theta is going to lie in quadrant 4. So we'll say that theta is in quadrant number 4. Okay, so in quadrant 4, the x values are positive and the y values are negative. So coming down here, we have the secant of theta, which by definition is r over x. So this tells me that the r value here is 5, and the x value here is 4. Okay, remember, we're in quadrant 4, so x values are positive. Now, I know my y value is going to be negative. Okay, so I have to be really careful. So let's get rid of this, and let's say that, and I'm just going to put this as negative something. We would want to say that r is equal to the square root of x squared plus y squared. So r is 5. So let me plug that in there. And x is 4, so 4 squared is 16. Okay, so what you would have here is square both sides. So let me do this. So this would be squared, and this would be squared. And so this would be 25 is equal to, if I square this over here, I'm going to have y squared plus 16. Now, if I subtract 16 away from each side of this equation, I'm going to get y squared is equal to 9. When we use our square root property, you would have y is equal to plus or minus the square root of 9, which is plus or minus 3. So again, because we're in quadrant 4 and the y values are negative, you want to make sure you choose negative 3. Okay, so that's very important. So now when we set everything up, let's say that we have our sine of theta, which is going to be y over r, so negative 3/5. You have your cosecant of theta, which is the reciprocal of this, so it's negative 5/3. You have your cosine of theta, which is the reciprocal of this. So the reciprocal of 5/4 is 4/5. You have your secant of theta, which is given to us as 5/4. Then you have your tangent of theta, which is y over x. So y is negative 3 and x is 4. So this is negative 3/4. Then you have your cotangent of theta, which is the reciprocal of the tangent of theta. So this is negative 4/3. So the sine of theta is negative 3/5. The cosine of theta is 4/5. The cosecant of theta is negative 5/3. The secant of theta is 5/4. The tangent of theta is negative 3/4. And the cotangent of theta is negative 4/3. All right, let's take a look at problem number 8. So we have the secant of theta is equal to 5/4, and the sine of theta is greater than 0. So when we think about the secant of theta, again, that is the reciprocal of the cosine of theta. So that's going to be positive in quadrants 1 and 4. Then when we think about the sine of theta, that's going to be positive in quadrants 1 and 2. So basically, we know we're in quadrant 1. So let me just put here that theta is in quadrant 1. Okay, so knowing that the x values and the y values are both going to be positive, we are given that the secant of theta, so the secant of theta is 5/4. And again, the secant of theta is going to be r over x. So r here is 5. And we know that x here is 4, and we just need a y value. Okay, so let me get rid of this. We'll write that in again in a moment. So let's come down here, and let's say that we have r is equal to the square root of x squared plus y squared. And again, for r, we know that's 5. And then for x, we know that's 4. And so 4 squared would be 16. And so we just need to figure out what is y And a lot of you can eyeball that and see that it's going to be 3 because you know that 3, 4, 5 is a Pythagorean triple. Okay, let's just go through it for the sake of completeness. So let's just square this and let's square this. So let's say this is 25 is equal to y squared plus 16. Again, subtract 16 away from each side, and you're going to have that y squared is equal to 9. If you use your square root property, you get y is equal to plus or minus the square root of 9, which is plus or minus 3. And again, because we're in quadrant 1, we know we want a positive 3 for the y value. Okay, so going through now, we just fill everything in. And we'll say that the sine of theta is going to be y, which is 3, over r, which is 5. Let me make this 5 better here. The cosecant of theta is the reciprocal of this, so this is 5/3. Then we have our cosine of theta, which is the reciprocal of the secant of theta, so this is 4/5. We're given the secant of theta, that's just 5/4. We'll just copy that. And then for the tangent of theta, this is y over x, so it's going to be 3/4, or just 3/4. And then lastly, for the cotangent of theta, you're just going to flip this tangent of theta, so that's going to be 4/3. So the sine of theta is 3/5, the cosine of theta is 4/5, the cosecant of theta is 5/3, the secant of theta is 5/4, the tangent of theta is 3/4, and the cotangent of theta is 4/3. All right, let's take a look at problem number 9. So we have the cosecant of theta is equal to negative 13/12, and the cosine of theta is greater than 0. So if the cosecant of theta is negative and the cosine is positive, well, that's going to put us in quadrant 4. Remember, the cosecant is going to be the reciprocal of your sine. So that's going to be negative in quadrants 3 and 4. And then if you think about your cosine function, it's going to be positive in quadrants 1 and 4, right? So that puts us, in terms of our angle theta, in quadrant 4. So let's say that theta is in quadrant 4. So now we know the x values are positive and the y values are negative. So coming down here, we have that the cosecant of theta, which by definition is going to be r over y, this is going to be equal to negative 13/12. So for this guy here, the r value, I'm going to say it's positive 13. So positive 13. And the y value is going to be negative 12 because, again, if we're in quadrant 4, the y values are negative. So what's the x value going to be? Well, we know it's going to be a positive value. But again, you could just plug in and say that r is equal to the square root of, you have your x squared, so x squared, plus y squared. So negative 12 being squared is 144. And let me plug in a 13 for r. And before we do anything, a lot of you, again, recognize that you have a 5, 12, 13 triangle in terms of your Pythagorean triples. So a lot of you can eyeball that and say, okay, well, I know x is supposed to be positive, so it's going to be 5. So if you get good at these, you can just skip this and just go straight to the answer. But for the sake of completeness, let me just square both sides here. And this is going to give me 169 is equal to x squared plus 144. Let me get rid of this. If we subtract 144 away from each side, you're going to end up with x squared is equal to 25. And again, by the square root property, x is equal to plus or minus the square root of 25, which is plus or minus 5. And again, because the x values in quadrant 4 are positive, you want an x value of positive 5. But again, if you recognize that you have, forget about the fact that it's negative, if you have 12, 13, then you know the other guy's going to be 5 because, again, it's a Pythagorean triple. All right, for the sine of theta, I'm just going to take the reciprocal of this guy, so negative 12/13. For the cosecant of theta, that's given, so negative 13/12. For the cosine of theta, this is x, which is 5, over r, which is 13, so 5/13. For the secant of theta, we're going to flip this guy, so this is 13/5. Let me make this better here. Then for your tangent of theta, this is y over x, so negative 12/5. Let's put the negative of 12/5 like that. And then for the cotangent of theta, let's go ahead and flip this. So this is negative 5/12. Okay, so the sine of theta is negative 12/13. The cosine of theta is 5/13. The cosecant of theta is negative 13/12. The secant of theta is 13/5. The tangent of theta is negative 12/5. And the cotangent of theta is negative 5/12. All right, for problem number 10, we have the secant of theta is equal to 17/15, and we have the sine of theta is less than 0. So we see that the secant of theta is going to be positive and the sine of theta is going to be negative. So again, the secant of theta and the cosine of theta, those guys are going to be positive in quadrants 1 and 4. Then for the sine of theta, that's going to be negative in quadrants 3 and 4. So we know our angle theta is going to be in quadrant 4. So let me put that theta is in quadrant 4. We know in quadrant 4, the x values are positive, the y values are negative. So if we're given the secant of theta, the secant of theta is 17 over 15. Well, again, the secant of theta is r over x. So I can say that the r value is 17 and the x value is going to be 15. Now, the y value here will be negative because we are in quadrant 4. Now again, if you know your Pythagorean triples, you know that 8, 15, 17 is a Pythagorean triple. So you can immediately answer that this is -8 if you want to, or again, you can go through the whole thing. If you're a little bit shaky on that, then let's just go through the whole thing. So essentially you have your r is equal to the square root of x squared plus y squared. So x here is 15. 15 squared is 225. And then for r, that's 17. And then if you square both sides, essentially, let me show this so that nobody's lost. You're going to get 289 is equal to y squared plus 225. So let me get rid of this. If you subtract 225 away from each side, you're going to end up with y squared is equal to 64. And again, from the square root property, y is equal to plus or minus the square root of 64. So y equals plus or minus 8. Because we're in quadrant 4, we want a y value that's negative. So you get y is equal to -8. So again, if you know your Pythagorean triples, it makes your work a little bit easier in some cases. And if you're a little bit shaky on that, then you can just go through the scratch work. It's not that big of a deal. So let's come down here and let's go ahead and say that the sine of theta is going to be y over r. So this is -8 over 17. So then the cosecant of theta is going to be the reciprocal of that. So -17 over 8. Let's say that our cosine of theta is a reciprocal of this. So 15 over 17. And then our secant of theta, which is given to us right here, is 17 over 15. Then we can say that our tangent of theta is going to be y over x. So that's -8 over 15. Let me make this 5 a little bit better. And then the cotangent of theta is equal to, take the reciprocal of this, so -15 over 8. We have the sine of theta is -8 over 17. The cosine of theta is 15 over 17. The cosecant of theta is -17 over 8. The secant of theta is 17 over 15. The tangent of theta is -8 over 15. And the cotangent of theta is -15 over 8.